stake, also abbreviated to POS, is the most common low-cost and low-energy consuming alternative to proof of work. Ethereum has shifted from POW to POS consensus. Proof of stake consensus mechanism has validators instead of miners. In proof of stake consensus mechanism, there is no mining to be done. The validator validates the transaction to earn transaction fees. In proof of stake, validators need to lock up stakes to participate in validation of transactions. Nodes are randomly selected to validate transaction data, but the probability of this random selection depends on the amount of stake locked. For example, if there are 3 validators on the network, say A, B, and C, their stakes are respectively 20%, 30%, and 50%, then it is ensured that C gets to validate 50% of the transactions, B validates 30%, and A validates 20% of the transactions. Proof of stake ensures the security of network because it is in the interest of validators to maintain the integrity of ledger, as they themselves have a stake in the network, and value of stake will depreciate drastically if any mischievous validation happens on the network. Apart from this, proof of stake mechanism also imposes penalties against validators trying to validate an invalid transaction. The penalties include confiscation of their stakes and withholding transaction validation fees. Now let's consider what pros and cons POS has over POW. We know that in the proof of work algorithm, each node that wants to participate in the mining of block has to solve a computationally difficult problem to ensure the validity of newly mined block. The miner with n fraction of computational power can mine n fraction of blocks. Validation using proof of work consensus requires specialized hardware, and the massive amount of electricity is consumed to run this hardware. Hardware requirement and enormous electricity consumption make proof of work inefficient from the resource point of view. Whereas in proof of stake consensus mechanism, no such specialized hardware is required and hence negligible resource requirement. This makes POS more efficient with resource point of view in comparison to POW. In POW consensus algorithm, the updation of data is relatively slow as blocks are formed at the interval of around 10 minutes. So, this system might not be used in the situation where the volume of data is enormous. Whereas in POS consensus algorithm, block is formed in every 14 seconds, much faster in comparison to POW. In POW consensus mechanism, attack on the network is possible if you have 51% of the computational power of the entire network. To gain that much computational power, one has to spend the vast amount of money, and it is economically disincentive to attack the network. In POS consensus algorithm, one needs 51% stakes in the network to successfully attack it, which is also practically impossible and disincentive for an attacker to attack network in which he has 51% stake. The blockchain protocols using POS are Ethereum 2.0, Tezos, Casper, EOS, Tron, and many others. Another variation of proof of stake is delegated proof of stake, also abbreviated as DPoS. In DPoS, consensus protocol blocks are validated by a predetermined set of users of the system who are known as delegates. These delegates are rewarded for their duty of validating the transaction and adding blocks to the blockchain, and punished for any malicious behavior like double spending attacks. In DPoS, the validator performs two functions. They verify the transaction and build blocks. They verify the validity of blocks created by other delegates by digitally signing it. Blocks created by one of the delegates is considered valid only if more than one delegate digitally sign it. And you may ask, how are these delegates elected? These delegates are voted on the real time by the stakeholders of the network. The voting power of stakeholder depends on stakes. Higher the stakes, higher is the voting power. It is essential that the delegates are chosen with the best interest of the network at heart, as they keep the network running smoothly and safely. In some DPoS versions, delegates need to show commitment by depositing his or her funds in the time-locked security account, which is confiscated in case of malicious behavior. This version of DPoS is known as deposit-based proof of stake. Stakeholders can withdraw their votes for a particular delegate anytime they want if the delegate is working maliciously. These elected delegates do not have rights to change any transaction details. However, as validators, they can exclude certain transactions from the block they are creating. But this has minimal effect as the next block will anyway include these transactions. You can consider these delegates a public notary who are not a party to any deal, but they play an essential role in verifying that specific individuals were involved in signing a particular contract at a particular time. Now let's consider pros and cons of DPoS over POW and POS. In DPoS, every stakeholder has influence that is directly proportional to their stake. In this way, nobody is excluded from influencing the network. Unlike other systems, like POW and POS, where a node having either most computational power or highest stakes end up validating majority of the transactions. The updation of the transaction in DPoS consensus mechanism is even faster in comparison to POS consensus mechanism. So, increasing order of transaction updation times will be as follows. Time taken to update a block by DPoS is less than that taken by POS, which is further less than that taken by POW. Critics of DPoS argue that this mechanism will also suffer from the same problem which any other democratic system suffers, that is, voter apathy. If most small stakeholders fail to vote, then the tendency of the system is to be controlled by few large stakeholders. There are other ways to establish consensus, though not that popular. Some of them are practical Byzantine fault tolerance or PBFT. Byzantine fault tolerant BFT is the feature of the distributed network to reach consensus agreement on the same value, even when some of the nodes in the network fail to respond or respond with incorrect information. The objective of a BFT mechanism is to safeguard against the system failures by employing collective decision making, both correct and faulty nodes, which aims to reduce the influence of the faulty nodes. BFT is derived from Byzantine journals problem. Proof of burn. With POB, instead of investing into expensive hardware equipment, validators burn coins by sending them to an address from where they are irretrievable. By committing the coins to an unreachable address, validators earn a privilege to mine on the system based on a random selection process. Thus, burning coins here means that validators have a long-term commitment in exchange for their short-term loss. Proof of capacity. In the proof of capacity consensus, validators are supposed to invest their hard drive space instead of investing any expensive hardware or burning coins. The more hard drive space validators have, the better are their chances of getting selected for mining the next block and earning the block reward. Proof of elapsed time. This is one of the fairest consensus algorithm which chooses the next block using fair means only. It is widely used in permissioned blockchain networks. In this algorithm, every validator on the network gets a fair chance to create their own block. All the nodes do so by waiting for a random amount of time, adding a proof of their wait in the block. The created blocks are broadcasted to the network for others' consideration. The winner is the validator which has least timer value in the proof part. The block from the winning validator node gets appended to the blockchain. There are additional checks in the algorithm to stop nodes from always winning the election, stop nodes from generating a lowest timer value. There also exist other consensus algorithms like proof of activity, proof of weight, proof of importance, least, proof of stake, etc. It is therefore important to wisely choose a consensus mechanism as per the business network requirement, because blockchain networks cannot function properly without the consensus algorithms to verify each and every transaction that is being committed.